goes through. This is why we start early. Alright, let me see if... Am I muted on there? Turn on my sound. Oh. Okay, my sound's coming through. Do you mind saying something?
Hey, how's it going?
Great, you're louder than I am. Alright. Yay, I like testing when nobody's in. Even though they'll all hear this in the recording. Hey everyone, thanks for joining us. As you guys can see, we'll be starting in about 2 minutes and 52 seconds, and I will remember to mute my laptop. So sorry if you just got an echo. If you guys have any trouble hearing me, please let me know so I can go ahead and adjust audio before we start. We have had some issues with Firefox having the Twitch chat up the last couple of times, so if Twitch chat is not showing up, if you could change browsers, more than likely that would probably fix the issue. Oh, yay, the blind hiker says hi. All right, hey, Christoph, if you could say something just to make sure that they're getting your audio stream as well.
Hey everyone, please also let me know if my mic audio isn't loud enough. I can always move it, bring it closer to me. So just let me know and we'll fix it. Did that come through okay?
Rayton, can I get a yes or no from the chat room? That would be great. Oh, sounds good, I got. Thank you. You know, the blind hacker, that's who's in chat right now, kind of helping us out. And a little bird told me he's going to be joining the Jupyter group at Texas Cyber Summit.
Very nice. Thank you for your help, by the way.
And Cheesy's made it into chat as well.
Familiar faces.
I love that it's a lot of the same people over and over. I can't wait to start hearing, you know, some success stories and what people, you know, I wonder, will people go off to Azure and do kind of the intro to Azure course? Will they continue through AWS? Maybe some folks will go OpenStack. I don't know.
I am really curious to find out too. I'd love to see some stats afterwards if people don't mind sharing of, you know, I took this exam, I passed it or didn't and tried a couple of times. But also then I moved on to these other things. Is it an AWS certification? Is it, like you said, an Azure cert or anything else? That'd be really interesting to find out. So please keep us posted.
Hey. All right. We're going to go ahead and wait the 38 seconds that we have remaining just to let people wander in. I'm so excited that today we had no mic issues. Of course, there's like one more left, but we had to figure it out eventually, right?
Knock on wood, please.
Knock
on
wood, yeah.
So far, so good, though.
Yes.
And one thing we've had happen the last couple of days is the power utility company is sending notifications saying, you know, there's too much power being drawn. Please try to minimize your electricity usage. So hopefully that doesn't happen in the next hour. But when it does, it's usually very, very quick. And I've got a backup UPS. So
that was really funny because right as you said that, we had our we had the stream kind of start buffering. So I jinxed us. Okay, so welcome everyone. We are back for our second to last, I guess, study group. It's a little bittersweet. I'm gonna be honest with you guys. I'm about ready to get this test taken and kind of go on to my next adventure, wherever they may lead. We talked a little bit earlier about how we'd love to hear about others' adventures to see kind of where they go. So definitely keep us posted. You can join us in the Slack. That's what we're talking about, in the study group Slack room. Christoph, how's this week been treating you?
Really, really good. As you can tell, my beard has grown out a little bit because I've been focusing on building this other study group. So I've been working really hard on it. I'm very excited to go through it. And like yourself, I'm actually really excited for this to come to a close because we've already started receiving notifications about people who have gone and taken the exam and passed the exam, even though we haven't even finished the study group yet because they've been studying so aggressively and doing a great job. And so I'm very excited to hear those pass rates and have that come back. And so if you do end up taking the exam, even if that's before we finish or after we finish, please let me know. I love hearing those success stories. And that kind of just really motivated me for this week too, of just getting this out of the way and helping as many people as I can pass the exam. So great week so far. Elle, what about yourself?
Doing good. You know, I kind of started going through, and I have the benefit of being a Linux Academy student as well, so started going through the labs and actually getting to do some hands-on with what we've been learning. So it's been a little bit of fun. I have my photos now going up to an EC2, and then I've got them set up to go into Glacier if I don't access them for a while. That way, if I lose my phone, I have a backup. So I thought that was pretty cool. Some practical
Nice.
use there. But you talked about people telling us that they're passing, and our group is very, I guess, swag oriented. You've seen them fight for those stickers. So I don't know, what do you think? Should we do a little giveaway to every person who kind of sends us back, what we should say, copy of the cert, or?
Yeah, I think there'll be a special surprise at the end if you do end up passing. I don't know. I've heard some details here and there. I think we still have to refine it. I don't know if it'll be everybody who passes or if it'll be a random drawing or something like that. But there's definitely going to be a special surprise for people who end up taking the exam and who attended the study group. So yeah, please let us know. We want to hear about it.
Yep, I think that we've managed to kill a little bit of time for the rest of the folks to go ahead and get in. So I know we have a lot to cover today. Let's go ahead and get this started.
Okay, I'll go ahead and share my screen. And please let me know when you're able to see the slideshow. Perfect. Okay, so like you mentioned, we have a lot to cover this time. I know I say this every time, but we are running out of time with these sessions. So I want to try and get as much good information as possible in these presentations. That way we can maximize how much we get out of them. But in this specific study group, what we're going to talk about primarily is around Amazon S3. You actually mentioned Glacier and being able to store images and things like that, and having backups. We'll touch on that quite a bit in this session. We'll also talk about databases and database services in AWS, how to migrate data to database services and other services like Redshift, CloudFront, and some other ones as well. So lots to cover, very interesting information and important information to know not only for the exam, but also if you're going to end up using AWS on a day-to-day basis. So with that, let's go ahead and move on and start with our homework quiz. I think we have 2 or 3 questions from the Cloud Practitioner PDF sample questions that we need to cover and covered last time, so that we should be able to answer these now. The first one was, why is AWS more economical than traditional data centers for applications with varying compute workloads? And the answer is C, because Amazon EC2 instances can be launched on demand when needed, and you don't have to pay for them when you're not using them. So that is a major cost benefit to using AWS. Question number 3 was, which AWS offering enables customers to find, buy, and immediately start using software solutions in their AWS environments? And the answer is Marketplace. You can pull up the Marketplace, launch EC2 instances from images. Those could be commercial, individual, or whatever else, as we saw in the prior study group. And the fourth question that you should have been able to answer now is, which AWS networking service enables a company to create a virtual network within AWS? And of course, the answer is Amazon Virtual Private Cloud, Amazon VPC. If you missed one of these questions, please check the bottom of that PDF. They have explanations and links to the documentation that can help you out. But also, if you missed the last study group and you're not really sure what these questions are even asking in the first place, please go back to that specific study group. We covered a lot of very important concepts in that study group about EC2 and VPC. Now let's move on and let's get started with Amazon S3. Amazon S3 is probably a service that you've heard of before for a number of different reasons, one of which is because it usually makes the news on a somewhat frequent basis in the news because of security issues. Somebody left permissions open, somebody was able to access some files they shouldn't have been, and then they leaked those to the rest of the world. That's a lot of times why we hear about Amazon S3, but of course there's a lot more to it than that, and there's a lot of ways that you can use S3 to secure your resources, so it doesn't have to be a scenario where you end up in the news for the wrong reasons. But in a nutshell, Amazon S3 is an object storage service that's built to be highly scalable, highly available, and secure and performant. Customers of really any size, you could be an individual. I use it for some individual storage. You could be a small to medium business, or you could be a massive enterprise scale company in any industry, and you can use Amazon S3 to store and protect any amount of data for a wide range of different use cases. One of those use cases could be, like Al mentioned, storing images or other files like that for websites, mobile applications, or even for backup and restore. If you have infrastructure on AWS and you want to back things up, you can use S3 for that. If you have resources on premises and you want to use offsite storage for a wide variety of great reasons, you can use backup and S3 for backup and restore. You can all use it for other types of applications and for big data analytics and a bunch of other use cases. Really, anything that can benefit from file storage at a large scale could be a use case for S3. When working with S3, there's really 3 different terms to think about when it comes to the structure of how you can structure S3, right? And the first one is going to be buckets. The second one is going to be folders. And the third one is going to be objects. And the graphic on the right-hand side kind of illustrates that a little bit. I actually pulled this graphic directly from our AWS Cloud Practitioner course on Linux Academy using an interactive diagram. In this case, it's not interactive because I took a screenshot of it, but in the course itself, you're actually able to interact with this content, which is super helpful, and that's why I put it up here. But diving a little bit more into it, what are Amazon S3 buckets? Why do you need to know what they are? We're looking at the right-hand side here. You have buckets with objects that are tied to S3 as a whole. So if you go in the S3 service, which we'll do in a little bit in the AWS console to show you what that looks like hands-on, if you go in S3 to get started storing objects, you have to create a bucket. And that bucket is where you dump your objects into. So that kind of makes sense, right? Where else would it go otherwise? This is going to be the highest level used to group folders and objects together, as I mentioned. And that way you're also able to apply bucket-wide policies to those objects and folders. So if you're wanting to tightly lock down security for an entire bucket, you can do that by enabling a permission or policy at the bucket-wide level that trickles down to everything else in that bucket. So that's a great way to secure resources and turn on other settings, important settings that we'll talk about. One interesting thing about S3 is it can also be used to host static websites. So you can turn a bucket into a static website. You could store an index.html file, some CSS files, images, and you'd be able to deliver a website to customers, especially if it doesn't need any dynamic elements like PHP or anything like that. So it's a very economical and easy way to create a static website. Like I said, economical in the sense of usually it's very, very cheap. You only have to pay a little bit for the storage and then a little bit for the people that access the site. The other thing you'll notice with this diagram here is you have S3 in the AWS cloud, but then you also have a region with the blue line here, and that region wraps the buckets and it wraps the objects and the folders. That's because when I create a bucket in S3, I have to select a specific region. Usually you'll pick a region that's closest to you or your end customers, because that way it's faster, there's less latency in accessing those objects within your bucket. So typically you'll just pick the region that is closest to you. The other thing to know about bucket names is they have to be unique across all of AWS. So they share a namespace, meaning that if I create a bucket called Christoph, Elle cannot go in and create a bucket called Christoph. But she could call it Christoph123, and as long as nobody else is using it, she'd be able to use it. You also have to stick to between 3 and 63 characters in length. Anything above that or below that won't let you create it. You have to stick to lowercase letters, numbers, and hyphens, no special characters. And you can't format it as an IP address like 192.168.1.1. That would not let you create it. But you could use hyphens, 192-168- whatever else, and that should work fine as long as it's not taken already. So that's a high level of buckets. Next, we have folders and objects, and then I'll take a quick pause to see if there are any questions. So the folders, they're not very practical in the sense of you can't really do a whole lot with them. They're more as a organization tool. So I create a bucket, I want to have multiple different folders to keep things tidy. I can create multiple folders and then I can store objects in those folders. And so when I navigate S3, it makes it easier to find exactly what I'm looking for. So in this case, I could have an object directly stored within the bucket without a folder. Then I could create another folder called My Project, and I could have my presentation object in that My Project folder that's separate from the spreadsheet. So it just kind of helps organize things. Objects do store, S3 does support a wide range of formats for objects. So it could be a text file, a PDF file, an image, a movie. I actually don't think there are any restrictions on the file format. I could be wrong. I haven't really tested all of it, but you can store a whole bunch of different formats in this. S3 doesn't really care. It just grabs it, stores it for you, and lets you do whatever you want with it for the most part. And once you do have those objects stored in S3, you can select the permissions for those individual objects. So we talked about bucket level wide permissions that trickle down to everything else, but you can also dictate specific permissions and restrictions at the object level. So if you want to have 5 objects that are publicly accessible that I can send to my friends or colleagues, and then I want to have one file that should be locked down, nobody should be able to access it but myself, I can absolutely do that at the object level as well. So you can control very fine-grained permissions for your objects and for your buckets, and that gives you two different levels of control there. Now, one other really important concept about objects is the ability to version those objects. And you can set versioning at the bucket level as well. But basically, if you upload an object and you want to make sure that anytime you upload another object, it doesn't override that one version that you uploaded previously. If you turn on versioning, it will do that automatically for you. And then you'll have access to all those different versions that you can then restore. You can preserve those things, you can retrieve them. And so if you make a mistake with a new object, you want to revert back to another version, you can always do that. That way that helps you prevent mistakes or anything like that. So versioning can be very helpful in preserving your objects and being able to retrieve different versions of it. And so that's an important topic and concept to understand as well. And I'll show you how to turn that on console when we dive into Amazon S3. Storage classes is a pretty important topic and a wide topic. So I'll take a moment to pause here and make sure there are no questions with buckets, folders, and versioning and objects before we move on.
So we've been having a little bit of conversation in the chat about, trying to name a folder or a bucket. I'm sorry, trying to name a folder and a bucket. There we go. Trying to name a bucket and you doing a bunch of random characters and it's like it's already taken. So maybe using a longer string will probably be helpful. But let's say that, you have the Christoph folder and you delete it. Could I come, or I keep saying folder instead of bucket. My apologies, guys. I don't want to lead you astray there. But you go through and you delete it. Can I later come back and start it, or once that name has been used, it's no longer valid?
As long as it's deleted and nobody else snatches it back up, you can absolutely use it. So if I delete Christoph bucket, you're able to create the Christoph bucket, yes.
Now, are there any best practices and naming conventions that are recommended?
I would say usually it's more of personal preference. There are some more technical discussions regarding naming, but also regarding how you store and organize objects and buckets for performance. But really, I think Amazon is kind of moving away from that. And even if they aren't, that's definitely a more technical topic for like the certified solutions architect, not so much for the cloud practitioner. So as for this level of conversation, not so much. It's more of your personal preference, how you're going to be using it, whether you're using it for apps. If so, maybe you have a naming convention for those apps already predefined. It's personal preference for the most part.
All right, thanks guys. I think that's all the questions we have right now. And if any of you want to do more of a technical deep dive into that conversation, please jump into the Slack. Christoph, myself, and some of our other training architects are in that Slack. Happy to continue that conversation.
Absolutely. Please don't hesitate to ask questions, even if it's quiet in there. If you want to private message us, that's totally fine as well. But please, we're here to help you out. So storage classes are a very important topic, not only for the exam, but for practical usage of S3. I'm going to go through them rather quickly. So I definitely recommend that you go through these bullet points again on your own after this by downloading the slides, and we'll send you the link for that. But the reason I'm going through it is because for sake of time, but also there's a lot of different bullet points between all of them. And so it's easy to forget. And this really takes reinforcement. But the thing with Amazon S3 storage is that when you store objects in S3, you have control using these storage classes over the expense of how much it costs to store these objects, but also things like the durability of the objects, the availability of the objects, how often they can be accessed, and things like that. So that's why this is so important. The default storage class, so if I just go in S3, create a bucket, and upload an object and don't change any settings, by default will be called the standard class. This is the most expensive storage class there is. It's not that expensive, but it is more expensive than the other options. And the reason for that is because it's designed for general all-purpose storage and usage. So it's a great default option. It's also great because it has what's called 11 nines of object durability. Keep in mind that these files you're storing it on the cloud, but you still have infrastructure storing that data. So it's kind of like if I have a computer at home or on my laptop, I have usually hard drives or solid state drives that store data for me. Those drives can die. They can fail on you, especially hard drives who are very sensitive to shock, who have life cycles or lifetime. I forget exactly what that's called, but after X number of reads or writes, eventually they die. They have a shelf life, right? They create massive arrays of these storage drives and SSDs, but there's still some failure that can happen. And so by selecting the storage class, you're actually under the scenes or behind the scenes selecting how durable and available that data is. 11 nines is extremely high durability. You are extremely unlikely to lose an object in Amazon S3 by uploading it to the standard class. As we'll see later, there are other classes that don't offer this durability, that can only be used for files that you don't necessarily care about as much or that you have backups for. Same thing with availability. 99.99% is very, very high, but that does mean that, and I can't do the exact math in my head right now, but within a given year, there may be a time when an application or yourself try to access that file and it's not available for that moment in time. You come back an hour later and it might be available at that point in time. So that's where availability really kicks in. And 99.99% is one of the higher availabilities that you can have with these storage classes. And that's the standard class. Then we have standard infrequent access. That's what IA stands for. This is designed for objects that you don't need to access frequently, but they do need to be immediately available when you try to access them. And one of the ways that AWS does this is by spreading your objects across multiple availability zones. So when you upload it, they automatically take care of storing it between multiple AZs, which means that even if a disaster happens at one AZ, the other AZ is still available. Therefore, you should still be able to pull that file. You can see here the object availability is a little bit lower though at 99.90%, and that's part of reducing the cost, but you still do have 11 nines of object durability. So you still need durability, you still need high availability, but you don't need to access it that often. Standard IA might be a better option for you to save money because it is less expensive. Some people may use this for disaster recovery or backups that need to be readily available in case of an emergency. So this is a good class for that. Another class that's similar is one zone IA or infrequent access. You can see here the object durability drastically drops. You go from 11 nines to only 4 nines. That's a significant difference over a given period of time of a year. Same thing with the object availability. It's a little bit lower, 99.50%. That can seem like not much, but again, over time, that's a fairly significant difference. But that also means that this storage class will be 20% less expensive than standard IA. Then you have intelligent tiering, which is fairly new and is really cool because apparently they use machine learning in the background to identify how often you access your objects. So it's designed to automatically optimize costs based on your object usage. And it does this by looking to see if you access a file for 30 days, and if you don't, it automatically moves it to another storage class and monitors those changes. So if you do access it, it pulls it back to a different storage class and so on and so forth, which gives you that 11 nines of durability, but you're also back to 99.90% object availability. And of course, the pricing depends on the storage class at any given time of where the object is. Elle mentioned this at the beginning. I'm really glad she did because this is an important topic as well. Another storage class is called Glacier and Glacier Deep Archive. These storage classes are designed for extremely long-term archival storage because it can take multiple minutes or even several hours to retrieve objects, but you have 11 nines of durability, making sure that this is a really good long-term storage option. And it's also going to be the cheapest option since really it's just kind of sitting there. You don't really need high availability access for it. You just need it there in case of an emergency. Deep Archive does have a longer storage minimum and is really only designed for objects that would be pulled at a maximum 1 to 2 times per year. It could be 0 times per year as well, but really if you're going to access it more than 1 to 2 times per year, you should not use Deep Archive. And they'll have those time restrictions and cost restrictions to make sure that you use it for the right purposes. This is also great for longer term backups, like a backup of a backup, for example, or usually a common use case is for files that you need to keep, whether they're financial logs or whatever else that you have to keep for regulatory reasons for like say 6 years, and you can't get rid of it, but you are 99.999% sure you'll never access that file. But if you do need it that one time in 5 years, then you'll need Glacier or Deep Archive for it. So that's where they really come into play. That's it for the storage classes, but there is another nifty feature that Amazon S3 has called object lifecycles. We talked about intelligent tiering. This is kind of similar, but more manual, where lifecycles helps you create rules that automatically transitions objects to those different storage classes after that threshold is hit. So you could say, after 30 days, automatically move all of these files, or I'm sorry, all of these objects into this storage class, or after 60 days or 90 days or whatever it is. This is another really good example of using it for log files. Maybe you don't need to pay for as much storage. You know you're not going to use them as much. But you can also use this to permanently delete those objects after that determined period of time. So if you want to delete the log files after 30 days, you can put that policy in there and it will automatically take care of deleting the files after those 30 days, as long as it hits that threshold. So object lifecycles are very helpful, but they are going to be more manual than the intelligent tiering storage class option that we talked about. All right, questions before I move on to a pop quiz?
It would help if I unmuted. Okay, so you went through that really quick, and one of the concepts that I want to make sure that everyone understands is you said you could go to access a file and it's not there, but then the next time that you try, it is there. Can you offer a little clarification on how that works?
How it works in terms of, like, if you have an application, basically you have to be okay with the fact that if, say you're loading a web page, this is probably not the best use case, but say you're loading a web page and an image just doesn't display, is that really the end of the world? If it's not, then that could be an acceptable use case, especially if you're trying to optimize costs. But if it's not completely deleted either, like it's not permanently gone in the ether, it might just not be available at that point in time. The durability on the other side, if it's lower durability, that object could actually be gone forever. So that is a key difference between durability and availability. Availability is it's maybe just not available at that point in time, but it will be available later on, and you need to build the application or whatever else you're using for those objects and keep that in mind so that it handles that situation properly. I don't know if that fully answers the question or not. I may need some clarification if it doesn't.
Okay, I think that's what unless I get further questions, I think they understand it. So I guess we're ready for quiz time, and I forgot to get the swag out so I can show off what they're competing for today. Or not competing, we're going to keep it friendly. But we're actually going to go with some of our It's Okay to Be New stickers. And you'll also, I mean, anybody who's won knows that they get a few other stickers in the pack. These are not available from anyone but me, so limited swag item.
Talk about limited. That's all. I don't think I even have one, Elle.
I don't think most people at LA do.
Very prestigious. And this pop quiz, don't worry if you don't get it right. Like we said, I went through this very quickly, but this is more of trying to help reinforce what we just covered. Please download these slides and read through them more attentively. But the pop quiz is, you're storing financial logs that need to be retained for 6 years, but that are extremely unlikely to be accessed during that time period. Which storage option will be most cost effective? Is it standard and frequent access, Glacier Archive, intelligent tiering, or standard?
Glacier Archive from the beginning is the clear pick.
Okay, nice. Good job. I think this one's a little bit more difficult. Let's see. You're storing objects in S3 and aren't sure which storage class will be the best for cost effectiveness, since you don't know how often the objects will be accessed. You do know they will be accessed a few times a year in random patterns. Which storage class should you select? Standard, one zone IA, intelligent tiering, or Glacier?
All right, and give you guys a second. I'm wondering if this one's hard because we're kind of getting a standstill. And we've got a little bit of disagreement. Wow, they're just gonna pick every single option and make sure that we're covered. All right, so standard is the only one with multiple votes, but other than that, they've picked everything else.
So for this one, I picked the intelligent tiering, primarily because intelligent tiering is really good when you're uncertain of what it will be, and you have random access patterns. Like standard is usually a really good one if you know it's going to be accessed quite often, say 5 times a month or 100 times a month. Standard would be good for that. If you think it will be accessed once a quarter or maybe sometimes 10 times a quarter, but then 0 times a quarter, intelligent tiering might be a better option because it could help move that object and save you a little bit of money in those quarters where it's really not accessed. And then when you do need it, it moves it right back to, say, standard when you do actually need it. So intelligent tiering in this case could actually save you a little bit of money. And that's why C is the correct answer.
So congratulations to CTKR there. He has won stickers at every single study group. I know his address well now.
Awesome. All right. One other thing I'll mention before we move on to actually looking at S3 in the console and also moving on to databases is something called AWS Storage Gateway. So we talked about S3 and storing objects and data in S3, but if you're an organization still using on-premises and you have applications that need access to your cloud storage, you can use something called AWS Storage Gateway, which will do a lot of things like caching data locally. That way you don't have to go over the network and transfer that data again. It caches it. You have much lower latency access, can also cut down on costs. And there's 3 different gateway types you can use. There's tape gateway, which is, if you've heard of tape before, very cost-effective, long-term, and that's more for the offsite data archiving. File gateway is really to upload different files to S3 for object-based workloads. And then volume gateway is more of the data backed up as a point-in-time snapshots for volumes, and that actually stores them as EBS volumes, or snapshots, I should say. And that way you could restore them into EBS volumes and attach those to EC2 instances. So you can back up those volumes to the cloud, and then you can restore them. This could also be really good for disaster recovery. If your infrastructure on premises goes down and you've got those volume backups, you can restore them in EC2 from the snapshots, gets you that point-in-time snapshot of what it was like, the state of it, and you can resume servicing customers that way. So again, use cases of this would be if you have a hybrid cloud on-prem and public cloud, if you have or a need for backup and restore or disaster recovery using AWS. But also another use case that this can help for is if you have capacity fluctuations with storage needs and you only have X number of storage on premises, you know you'll have a spike for a limited period of time. It may not make sense to buy more hardware just for that fluctuation. So instead, you could offload some of that fluctuation to the cloud, and AWS Storage Gateway can help you do that as well. So just a little bit of an overview of AWS Storage Gateway, if that does happen to pop up on the exam. It is an important thing to know, but I wouldn't say it's a huge portion of the exam by any means. So now let me actually move over to the AWS console really quickly so I can show you the S3 interface. If I can find my mouse, there we go. So when you go into AWS and log in, you can search for the Amazon S3 service and it will be able to pull up that service. Once it finishes loading, you'll see that I have no buckets right now. I can create a bucket by clicking this button right here. And then I could see, let's do Cloud Practitioner Study Group. And you'll notice sometimes it turns red because it's used. I can't use that name. But also here, I need to select that region. So remember, you do need to select regions when you're creating these buckets. And I'll go ahead and just do US East North Virginia. I don't have any other buckets, so I can't copy settings from those buckets. But if I had other buckets, I could copy settings directly, which would speed things up. Then I move on to the second step, which is configuring options. Here I can enable versioning. We talked about versioning. I can also enable something called server access logging, which just logs requests for access to your buckets, that we can see who's accessing it or what's accessing your buckets and run some analysis on that, primarily for security reasons. Tagging with key values helps you organize things. You can have object level logging. We'll actually talk about logging in the next study group since it's an important topic. Default encryption, so you can automatically encrypt objects when they're stored in S3. You can enable that and select how you want to encrypt them. And you have advanced settings with object lock. We won't cover that here. And CloudWatch we'll also cover in the next study group. Then you have to set permissions. By default, every public access is blocked. So if you uncheck this, you can fine-grain control it a little bit more. But again, by default, because of a lot of the security leaks that S3 has seen, they've made it a lot easier to just completely block all of it with a click of a button. That way there can be fewer mistakes that happen. And then we'll move on to the next step to kind of review, and then we can go ahead and create that bucket. Now I have this bucket called Cloud Practitioner Study Group. I can click on it. I can look at properties. There are some properties we could have configured during the creation and some properties that you have to configure after the creation. Versioning is one that we could have, server access logging, static website hosting, if you remember that, object level logging, encryption, tags, and so on. So you do have some properties that you can manage there. You can go to permissions. You can block public access easily. They also have something called an access control list. I'm pretty sure this is not covered in the exam. I don't remember it being covered in the exam, but maybe double check. your understanding of this to make sure that you don't get surprised by it. Bucket policies are also another way to control what can access certain things in your bucket. And course configurations is another technique. So as you can see, there's like multiple ways of controlling access to your buckets, and it kind of depends on the use case. Course configuration is usually for web applications that are loaded on different domains, and by default, it might block it because they're on different domains unless you properly configure your core configurations. So there are ways to manage permissions there. Lifecycle policies, analytics, and some other settings that you can see here. You can upload an object, set permissions for the object, set properties, and review, all of which we talked about in the slideshow. And I would love to show it to you. Unfortunately, we're not going to have time for that. But keep in mind, we do have hands-on labs for this on Linux Academy, where you can actually do it yourself and walk through the steps, which I highly recommend doing if you have an account. That way you can get your hands on it and actually see what that looks like and how it happens in the AWS environment. Any questions about anything related to S3 that we covered before I move on to databases?
I think you're doing good. We're at about the halfway mark, so let's keep going.
Perfect. Okay. When it comes to AWS database services, there are two main ones we're going to talk about today. The first one is Amazon RDS, and the second one is Amazon DynamoDB. The main difference between these two services is that RDS is a service for relational databases, which a lot of people often refer to as SQL. And then DynamoDB is a service for non-relational databases, which a lot of people often refer to as NoSQL. If you download this slide and click on this link, I have an article and video that talks about the differences between NoSQL and SQL in a lot more detail. I don't have time to cover it today, but if you're curious to know more about that, that's a really good way to get that information. But just to kind of visualize the differences, NoSQL typically has key value storage and will be formatted in JSON. So you could have a key such as a name like Steve, Dave, Kathy, Jill, Bill, Donna, and then they could have a value of status active or retired or inactive. And that way you can just query this entire table and see the key values, or you can query specific keys in order to get the value of that key. On the other hand, with SQL or structured relational databases, you'll typically have multiple different tables, and those tables will have relationships between each other. So in this case, I have customers' information in one table, billing information in another table, and images uploaded. And if I need to pull information that crosses these three tables, I can use SQL to run a query against my database that pulls that information from all three of those database tables and returns the value of my query. So it's a lot more structured. There's a lot more that goes into kind of thinking through how to structure that database versus DynamoDB doesn't really care so much about the structure. It's just like, here, give me data, I'll spit it out when you need it, which of course has pros and cons that we'll talk about. So let's talk more specifically about RDS, and then we'll show that in the console, and then we'll talk about DynamoDB a little bit more as well. If we copy the marketing language on the Amazon RDS AWS webpage, they say that Amazon RDS makes it easy to set up, operate, and scale a relational database in the cloud. It provides cost-efficient and resizable capacity while automating the time-consuming administration tasks like hardware provisioning, database setup, patching, and backups. So it claims to do a lot for you, and it's able to do a lot of things for you because they've built this as a service that abstracts away a lot of that complexity that you otherwise would have to deal with if you were setting up from scratch. The other cool thing about RDS is there are many different database engine options. There's a ton of them out there. But RDS offers, I think, 5 or 6 different ones. You have Amazon Aurora, you have MySQL or MySQL. It's usually said MySQL. I always say MySQL because Microsoft background. Sorry about that. MariaDB, PostgreSQL, Oracle, Microsoft SQL Server. And those can be selected at the time of creation. So you can go into RDS and you can say, I want a MySQL database. Go ahead and configure that. Or I want a PostgreSQL database. Go ahead and configure that. I have flexibility over the engine that RDS uses as long as I pick one of those. And we'll talk more about Amazon Aurora because it's a fairly significant service that they offer that lives within RDS. The other thing with RDS is you can actually select instance types to be used. We saw this with EC2 where you can select the instance type depending on your use case. Same thing happens here. You can select things like memory optimized or performance or IO optimized, which is more about the disk be able to pull information from disk quicker. So you can select the instance type depending on the use case for your database that you'll primarily be using it for. So again, to recap with RDS benefits, one of the benefits is scalability with just a few clicks. You click a button, you select an option, and you're able to resize that database. And if you do it properly without any downtime at all, which if you were to do that manually would be quite a bit of an undertaking. So they've really abstracted that complexity out of there. It's also very cost efficient. And I put the quote there for Amazon Aurora, which they claim is 1/10 the cost of other commercial databases like Oracle, Microsoft SQL Server, and things like that. It's highly available by nature. You can easily create read replicas across multiple availability zones. So you have that master write replica and you have child read replicas. The application you're using can pull data from read replicas, which alleviates load from the write master. And then when it needs to write to the database, it can send those requests to the master that then get propagated to the read replicas. And if something happens to that master, RDS can automatically switch the read replica to be the master. And then you still have other read replicas across availability zones, which again can increase high availability and fault tolerance. So it's an important topic. The other cool thing with this is kind of along the same lines, you can automatically apply patches and backups without causing any downtime, which again would be quite difficult to do if you were building this from the ground up. So there's a lot less upfront effort. You basically specify options and they kind of take care of it for you in the background for the most part. Any questions about RDS before I move on?
Yep, we had a few come in and I'm going to try to read them to the best of my ability here. It says, do you limit the size of a database or are you charged as it scales? I'm thinking about when a database corrupts because of something like running out of disk space.
Yes, and that's a great segue into Amazon Aurora because with Amazon Aurora, they claim that it features a distributed, fault-tolerant, and self-healing storage system that auto-scales up to 64 terabytes per database instance. Amazon Aurora technically lives in the RDS service, but it's a service that AWS pushes very, very heavily because of some of these self-healing properties and other properties that it offers, which is a great competitor for other commercial grade databases. So they kind of position this as a replacement for Oracle database, for Microsoft SQL Server databases, and for other types of databases you might be running somewhere else, like on premises or anything like that, that offers some of that resiliency you expect to get from commercial grade databases. So yes, long story short, there is that possibility. Usually you pay more for those types of features though. So something like Aurora will definitely be more expensive than if you're running it on your own using Amazon EC2 and EBS volumes, but it reduces a lot of that complexity that you otherwise have to have your engineers focus on. I know I moved ahead, but were there any other questions about RDS?
There is one more, and we might have to ask for clarification, but I'll read it to you just in case you can get the gist of it. And it says, how is RDS cost 1/10 as compared to the other commercial databases like Oracle or, well, they said MS SQL. So, and then it says, when are we configuring Oracle or MS SQL as we start RDS? So,
okay, I think that's two separate questions. So the first question is, honestly, I copied that directly from their marketing website. So read between the lines there. It's probably, they probably ran some case studies or did some market research and came up with that number. It sounds really good on paper. In reality, I don't know how often that is the case. So again, read between the lines there. For the other answer, I'll go ahead and jump into the AWS console to show you how and when that's configured right after we go through this section on Aurora here. Cool. Were there any other great questions?
I think you're good here. Oh, sorry, we just had one come in. Okay, this is more about the quizzes. So anyone who is new here, if you see a quiz question, just go ahead and answer in the chat. They're asking if we have bots to handle everything. I am your friendly bot, so have patience. But yeah, just go ahead and ask any questions or answer any quiz questions in the Twitch chat. Thanks.
So now is probably a good time to announce that we have a revolutionary new AI called Elle. So Elle is actually AI. She's not a person. No, I'm kidding. She's fantastic. Thank you for doing that, Elle. That helps a lot.
There you go. There's Alexa, there's Google, Siri, and me.
There's L.
I know.
New
All right.
announcement. I jumped the gun. So the other thing that they say about Aurora is that it delivers high performance and availability with up to 15 low latency read replicas, which is a lot. Of course, you have to pay for those replicas. A point in time recovery. So if something happens, click for that point in time recovery and it will bring it back up to speed. Continuous backup to Amazon S3, that kind of ties into that point in time recovery, and replication across 3 availability zones. If 2 availability zones go down because of a natural disaster, you still have that third one. Your database is still servicing customers. So benefits of Aurora, it's backed by RDS, which means fully managed by it. You have all the benefits of RDS and more, and it's highly, highly scalable and highly performant, even beyond some of the other RDS benefits that are provided there. So again, they're focusing a lot on this service. They're trying to get a lot of customers to migrate to it because really once you're inside of a database, it's kind of hard to get out of it. And so they want to try and get as many people to use this and migrate to it. They also claim that it is up to 5 times faster than MySQL and up to 3 times faster than PostgreSQL. So they make a lot of claims about Aurora, and I've heard good things about it. So I think it's a good service. Okay, let me go ahead and pull up the console so we can quickly go through RDS before moving on to DynamoDB. If my mouse would stop hiding, thank you. All right, so if we move to Amazon RDS, you'll notice right away at the very top, Amazon Aurora. You should use it. You can create a database here and that will kind of pre-populate the Aurora settings, or you can also go down here, restore from S3 if you have backups, or just click the orange button, create database. Let me go ahead and hide this here. So from here, you can do an easy create, which gives you best practices, kind of helps speed up the process, or standard create, which gives you more empty settings that you have to fill in yourself. Right away, you're presented with the engine type because depending on the engine type will change the other settings that you select. If I click on Amazon Aurora, that will obviously use that engine. I can select MySQL, MariaDB, Postgres, Oracle, or MS Server. And of course, here I have even more addition options. So this does change the options depending on the database engine that you're using. You can also select different versions. So if you want a specific version of MySQL because your current database or application is using that version of MySQL, then you can still do that up to the limit that they offer for, and so on. You have templates, like if it's going to be a production database, dev or test database, or if you want to stick to the free tier. You have identifiers and a bunch of other settings that you could expect from a database, like passwords, usernames. You have the database instance size that we talked about. You can select from this drop down here. You can select the storage type. If you want SSDs that are highly optimized for random read write or just general purpose, you can select that, the size of it, and so on. A lot of different settings, including which VPC you want to install this database inside of, which again, keep in mind, you want this to be behind a private subnet the majority of the time so that the database is shielded from the public access, but your applications or your engineers can still get access to this database. And then you can see the estimated monthly cost. So in this case, you're already talking about a little bit over $600 for a provisioned IOPS SSD of 100 gigabytes and a db.m5.extra large database, which is definitely not their largest size. If I select this beast instance here, you can see you're up to $12,000 estimated monthly costs. So this can make a significant difference in your billing, depending on what you select. But you have a lot of flexibility. And again, think about if you've ever installed a database before, or if you haven't, trust me, it's a lot more complex than just filling in these options and pressing a button. But also, you may not end up with this massive bill. So it's kind of a trade-off that you have to look at there. And we'll actually have a pop quiz on that. So make a mental note. Any questions before we move on to DynamoDB?
No questions yet, but we did have some fun conversation in the chat letting us know that they think that it's the administrative cost, having a Linux administrator or MySQL administrator that does the cost offset there.
That's a good point. Are you looking at how many engineers do you need? How much do they cost versus how much does this cost? How much time? There's a lot that goes into it for sure.
Oh, hold on. I spoke too soon. We've got some questions coming in. It says, let's see, how to create a read replica DB. Okay, so basically, could you create like replication and things like having a master slave, setup through using, the resources available in AWS?
Yes, and they make it super easy. You can click a couple buttons and it does it for you. So in this case, I think it's on this page. So even here, you can see multi-AZ deployment, create a standby instance recommended for production usage, creates a standby in a different AZ to provide data redundancy, eliminate IO freezes, and minimize latency spikes, or you can select not to. So it's kind of like this. You can just click buttons, and it will automatically provision those read replicas for you, and you can select how many you want, across which subnets. You have complete control over that, yes. You can also promote one. So if you want to manually do some kind of backup or something like that, you could always promote the read replica to be the master node and vice versa. So there's a lot of flexibility as you would expect from this kind of service.
Now, are there costs associated with things like administration? For example, if AWS has to do security patching, or there was a few other things, patching or security upgrades, changeovers, things like that are based around the administration of MySQL itself or the database itself?
So some of those are going to be built in to the monthly costs right away, especially if you're launching read replicas. Some of them I'm sure do have fees. I'd recommend pulling up the RDS pricing page because they do change it sometimes, and I haven't checked it in a while. And that way you can see a breakdown of all the fees that are associated with RDS.
All right, that was the last question we had in, so we're good to continue. We have about 15 minutes left.
All right, DynamoDB. So DynamoDB, as we talked about, is a key value and document database with very high performance. They claim single-digit millisecond performance, which is quite impressive. And so it's comparable to other NoSQL database engines, kind of like MongoDB or CassandраDB, if you've ever worked with those or heard of those before. Benefits of DynamoDB is beyond just the NoSQL benefits of it's fantastic for unstructured data. You also, kind of like RDS, or actually very similar to RDS, it's fully managed. You can have it multi-region and it's multi-master, so it's very reliable as well and extremely fast. It's got built-in security, built-in backup and restore, and built-in in-memory caching that a lot of times you don't even have to configure yourself. They configure for it automatically for you when you create the table. So yes, you do have some settings you can look at and tweak, but some of those it's just baked into it. You don't even have to think about it. And so that can also, versus installing MongoDB yourself and having to configure all of that, that could save you weeks of work, if not more than that in some cases. And so again, that is a great benefit that usually comes with an additional cost attached to it. Some common use cases for that would be things like mobile applications. Oftentimes they use NoSQL databases like DynamoDB or other web applications as well. Gaming, ad technology, IoT, things like that. This is by no means all the different use cases, but really anything that can benefit from extremely high performance and scalability that does not require structured data can use something like DynamoDB. I'll show you DynamoDB in the console in 1 second, but one of the questions you might have right now is, why would I use something like RDS versus DynamoDB or vice versa? Just to recap, RDS is when you need an SQL structured database option. Your data has to be clearly defined and clearly structured. You need something easy to set up, highly available, fault tolerant, and scalable. And again, common use cases of that could include something like an online store where you have a lot of intricate relationships between products, customers, listings, and things like that, or banking systems. DynamoDB is great for a NoSQL option when your data structure or is very unstructured or might even need to be fluid and change very frequently. That doesn't require schema. That's a great use case. Fast, highly scalable, fully managed. Common use cases of this, again, include things like social media and web analytics. So let me jump in so we can quickly see the interface for DynamoDB. That way you can compare it to what RDS looks like. Right away, you'll notice it's a lot simpler to set up. You have far fewer steps to go through, and you don't even have to select a database engine. There is no database engine to select. You just put in your table name. You have something called a primary key, and we won't really dive into partition keys, primary keys, and sort keys. We have some really good content on Linux Academy that delves into that a lot more, but that's kind of how you structure your tables and how you're able to pull data from those tables for your applications. And then using default settings, you'd have no secondary indexes, certain capacity for reads and writes, so that can impact performance of the application, alarms that are set by default, and encryption at rest with default encryption type. But you can also modify those settings if you want to. That does also change costs and so on, especially if you want on-demand capacity, that can definitely increase the cost as well, and some other settings that we won't delve into too much in this conversation here. Once you've configured it, you create the table, and similar to that graphic I had before with keys and values, you can start populating your database in DynamoDB, and you can start pulling that data using an application or even manually through this interface once you've created this DynamoDB table, which right now I don't have any. So that's what DynamoDB looks like. Again, very different from something like RDS, and it could also save you on cost, especially if you don't need a structured database. Another important question to think about is AWS managed versus customer managed. So RDS and DynamoDB is what we're going to call AWS managed. Customer managed would be EC2 with EBS volumes that backs those databases, which is completely doable, completely feasible, and some people do that, I'm sure. But why would you use one over the other? Well, again, it really comes down to how much effort do you want to put into controlling and configuring your databases in-house versus using AWS services that does it for you and hides some of those settings from you. With EC2, you could jump into the box directly, troubleshoot things, configure things. With RDS and DynamoDB, not so much. You have a lot more restrictions in that case, but it's thinking about that trade-off from your business resources and a business objectives perspective. Let's do a quiz real quick, and then I'll check to make sure there are no questions. This first pop question is, your startup company has limited engineering resources and needs to launch an application as fast as possible in order to monetize it. This application will require high availability, fault tolerance, and scalability since it expects a ramp up in traffic shortly after launch. This means your database needs to be resizable, and if the master nodes fail, it needs to have a read replica as backup. Which of these options would make the most sense for your startup? Is it Oracle database, Microsoft SQL Server, database on EC2 with EBS backed volumes, or is it Amazon RDS?
We have Amazon RDS as a clear winner in the chat.
Good job.
They didn't even give you a chance to take a drink.
Yeah, I know. Second question, I think a little bit more difficult here. Your organization is running a massive scale web application that requires an extremely fast and scalable database option. The data to be stored doesn't have a rigid structure and can change and be accessed frequently. Which of these options is likely to be the best fit for your needs? Is it Aurora, RDS like Postgres or MySQL, DynamoDB, or again, EC2 EBS backed?
All right, letting answers, and it looks like Amazon I can't even say it. Yes, Dinosaur DB is the clear winner.
Okay, good job.
Cannot
Very
unsee
nice.
now.
Awesome. I know I'm moving through it quickly, but we only have 6 minutes and I've got some other things to talk about. But before I move on to the other services, I do want to mention that AWS has created a service called Database Migration Service that helps you migrate databases to AWS or even within AWS. So if you have Oracle running, they will be able to pull your data and migrate it to AWS via Aurora, Redshift, DynamoDB, or S3. Or if you're running EC2 instances with databases on there, you can also migrate it to something like Aurora, RDS, or whatever else using DMS. The great thing about DMS is it automatically replicates data changes. So if it takes half an hour to migrate the data and something changes during that half hour, it automatically takes care of that change. And you can do continuous replication for, say, a month. If your migration is going to take a month, it can handle things like that. With no downtime, continuous data replication, and I've mentioned the other two as well. Any questions about what we just covered before we move on?
We had some questions that were basically, well, would this be more expensive, kind of price comparison. So in the chat I currently linked the Amazon RDS pricing guide, and there's also a calculator on there that you can go through and play and kind of do your specifics to get an idea of costs. So
absolutely, good point. All right, outside of databases, there's something else we can think about, because databases are great for long-term storage, where you need to be able to pull that information, run computation against the information, and serve customer requests. But a lot of times the problem with that is, especially as your application starts to scale and serve more traffic or run more complex queries, it could slow down that application or that database quite a bit, or even bring the database down to its knees where it's not able to service customers anymore. And so one of the services you can use to cache some of the data that's being served from databases or even other data is called Amazon Elasticache. Elasticache, if it's used properly, can really help improve the speed and performance of your web applications because it serves data directly from memory instead of from disk, which is significantly faster than storing data on SSDs or disks. And it uses technology called Redis or Memcached. So similar to RDS, where you can select the database engine. In this case, you can choose either Redis or Memcached, two very popular options. Redis is insanely fast. Memcached has been around for a long time. And you can deploy and run and then scale that the Elasticache services in order to handle demand and relieve some of the demand from your databases. It can also be used for bypassing the database for data that you don't really care if it goes away at some point, because the downside to something like Elasticache is because you're using in-memory storage, if the power goes out, if your server goes down, if you run out of memory to store data, then the data is going to be erased. And even if you create backups, you may still lose some data. So this is not really meant for long-term storage for the most part. It's meant to cache data and then get rid of that data, serve it really quickly, get rid of it, and so on to help performance and speed of your web applications, which is very different from something called Amazon CloudFront. We talked about CloudFront a little bit in the past, especially in the first study group, but CloudFront is a content delivery network, or CDN, that securely delivers data, videos, applications, or even APIs to customers at a completely global scale with very low latency and very high transfer speeds. So a caching system, you might store data that's been computed from your databases, for example. With a CDN like CloudFront, you could actually store videos, chunks of videos, or entire videos. You could store other types of data. You could help accelerate APIs. You can do a whole lot of things closer to the customer and to the end user. And because CloudFront is directly integrated in the AWS global infrastructure, it provides very, very low latency. So let me give you an example. Say you're using S3 to store images or store videos, and S3 is in North Virginia, but you have a lot of customers in Europe. Unfortunately, the data can only travel as fast as the speed of light. Even with fiber optic, you're still limited by the speed of light, and the globe, our planet, is very big. So that data has to travel extremely long distances and is limited by the speed of light. So it has to go across the Atlantic Ocean to reach Europe, which isn't that far, but wouldn't it be better if you had that data stored in Europe directly without having to set up another bucket in S3? Well, that's where CDNs like CloudFront can step in, because if somebody in Europe tries to access that video in North Virginia and CloudFront doesn't have it the first time, it will go fetch it in S3, store it and cache it in the CDN, that edge location, and then serve it directly to European customers, which means the more it's used, the faster and faster it becomes. So CDNs are very helpful for speeding things up, sometimes reducing costs as well. It also directly integrates with a service called AWS Shield, which is meant for DDoS mitigation. So if you get attacked from a DDoS attack, and if you don't know what that is, I definitely recommend looking it up. The Shield service combined with CloudFront can help mitigate those attacks and relieve your backend infrastructure from receiving too much traffic, more than it can handle. We talked about Amazon S3. It can also be in front of load balancers like the ELB, Elastic Load Balancer, or Amazon EC2 instances to serve applications. It can be used with Lambda at Edge, which is oftentimes used for IoT to run custom code closer to your customers' users. And it can be used with Route 53, so you can actually shift traffic using Route 53 to either go to your CloudFront CDN or to bypass it or things like that. So it works with a lot of different services is the point that I'm trying to get across here. Of it integrates natively with those services in AWS. It makes it a lot easier to deploy a CDN. I know I'm running out of time here. I'm almost done. I would say probably about 5 minutes like last time. If you have to run to another meeting, thank you for joining. Please download these slides and check out the next few slides. There's some important information there. If you're able to stick around, please do so. I don't have to go anywhere. Elle, I don't know if you do. If you do, stop me.
Nope,
but otherwise,
we're good.
Awesome. We'll keep going for another 5 to 10 minutes. Some other common use cases of CloudFront is going to be video delivery, as I mentioned, static asset caching. So if you have any JavaScript files, CSS files, HTML files, or even images, those don't change that often usually, or even if they do, you can force that to change in the CDN. But because they're static assets, you can also store those in the CDN, again, closer to the customer. And so instead of them having to go across the Atlantic Ocean to pull those files, they can be stored very close to them, which can speed up your web application performance. Slack used to, I don't know if they still do this or not, but they had a use case with CloudFront where they used CloudFront for API acceleration and DDoS mitigation. So when you use the Slack API, typically that was going through the CloudFront CDN, and that made API responses a lot faster because it could cache responses instead of having to compute those responses every single time, which also helps if there's a DDoS attack from overwhelming your infrastructure. Any questions about CloudFront before I move on to, I think, what is our last topic?
We just needed a clarification point that CloudFront is utilizing edge locations.
Absolutely, yes.
All right.
Yep. Awesome. So Redshift is, threw this in there because it has to do with data, but it's also very different from everything else we just talked about up to this point, because Redshift is a data warehouse service designed to handle humongous petabytes of data for analysis. So in the realm of big data, with all of these companies collecting huge numbers of data and not really knowing what to do with it, something like Redshift can really help out, because other traditional tools can't usually handle that scale of data, but Redshift can. And it can use standard SQL and other existing business intelligence tools to be able to analyze all of that data from a data lake. So a data lake is really just somewhere where you store a tremendous amount of data, and that data could be structured or unstructured. It doesn't matter. You create a pipeline that just dumps all that data in what they call a lake, and then you can use Redshift to make sense of that data lake. So the benefits of Redshift are that you can run very complex queries against massive amounts of data using sophisticated query optimization and massive parallel query execution. You can do that without having to move the data, which is a big deal when you're talking about huge amounts of data, or either without having to transform it into a set schema. So if it doesn't already have a set schema, Redshift can still handle it, no problem. And you can use Redshift to query that data, again, directly from the data lake, or in combination with a data warehouse that you might have somewhere else as well. So it doesn't have just be that data lake. It can handle another data warehouse if you have one. Common use cases of this, of course, is going to be business intelligence, predictive analytics with machine learning, real-time streaming analytics, and really anything that has to do with large sets of data. Let's do a pop quiz, and then we'll check to see if there's any questions. But let's say that your engineering team is in charge of running a video streaming service to deliver content to your customers, but they've started receiving complaints that certain parts of the world have longer buffering time than other parts of the world. Which of these services would be best to help solve this issue? Would you use Elasticache, Aurora, RDS, or CloudFront? And while people decide that, by the way, I really don't like the name Aurora. I have a hard time saying it for some reason. It's kind of weird.
Well, it looks like our clear winner is going to be Amazon CloudFront.
Yeah, awesome. Good job. Your engineers have created a large data storage pipeline to send structured and unstructured data to Amazon S3. Now they need to run complex queries to analyze and make sense of this data. What should they use? Would they use Redshift, Aurora, DynamoDB, or RDS?
Give people a chance to answer. This one gave folks pause, but we see the answers coming in for Amazon Redshift.
It is Redshift. The pause was probably because of Amazon S3 versus data lake, but S3 could be used as a data lake, so that could be the data lake itself. And because you're running complex queries to analyze and make sense of huge amounts of data, Redshift is a great winner here. And that wraps it up for this presentation. I didn't lie, it took 5 minutes. Some quick household items here and some homework. Please make sure you download the presentation slides and review this. I know I went through it pretty quickly. There's some really good information in these slides to make sure to understand. If you have any follow-up questions, I'm serious, go in Slack, ask us. We're not gonna bite, we're here to help. That's what the channel is for. Also download those sample Cloud Practitioner PDF questions. Now you'll be able to answer number 2. You'll be able to answer most of the questions on there at this point. There's just a few we'll cover next time. I also threw in some Amazon S3 hands-on labs that we have on Linux Academy. We also have hands-on labs for the other services we talked about. Feel free to check those out, but keep in mind, you don't need a whole lot of very technical knowledge for the other services we talked about, at least not for this specific exam, so don't freak out over it. And then for the next session, please read up on the service CloudTrail, CloudWatch, and SNS, and Lambda, because we will be covering those next time. And next time is going to be September 25th. So please mark your calendars, RSVP on meetup.com, and download these links and resources, join our community channel and our Slack channel. And again, thank you so much for attending. I really appreciate it.
Hey guys, I made the, I guess, executive decision to kind of bypass some of the questions that were being asked about optimization of Redis and other higher, I guess, level concepts. However, please join the Slack. It's not only the study group. There are DevOps channels. There's probably a database channel in there somewhere that have other students who are going through it, as well as our course authors and just subject matter experts who I'm sure would love to get into these conversations. So please don't feel that I ignored them because I didn't think they were valid. We just kind of have to focus the scope of what we're studying. All right, until next time, guys, you guys have a great day.
Thanks, everyone. Bye-bye.